Hello. Today we are going to discuss our project, that is RTU. RTU stands for Remote Terminal Unit and forms a very basic part of the modern power system protection. Power system is expanding day by day and the ever-growing power system requires new techniques for its protection. There are three basic fundamental blocks of a power system protection. The first one is transducers, which consist of current transformers and potential transformers that are capable of fetching the line current and line voltage and giving it to relay. Now relay is like a guard. It continuously monitors the current and voltage parameters and other parameters in a circuit and sees whether there is any abnormal condition or not. If there exists an abnormal condition, it will immediately send a trip signal to the circuit breaker, and circuit breaker is a switch that will isolate the faulty part. This is a power system protection at a glance. Now, as far as relays are concerned, they have evolved over time. The first relays were electromechanical relays, followed by static relays, followed by digital relays. The latest relays today are numerical relays. Now numerical relays use microcontrollers and are very fast and quick, and therefore are the new trend in power system protection. Now what is an RTU and how is it different from a numerical relay? An RTU, along with protection, also does the communication part. That is, suppose you have a distribution transformer or a transformer at a location which is far away from your substation. The RTU will continuously monitor that equipment. Now suppose there is a fault in that equipment. The RTU will act as a numerical relay and immediately detect the fault and gives a trip signal to the circuit breaker so that the equipment can be isolated. Along with that, the RTU, what else it does is, it will communicate the action taken to the master station or the substation. Now how are we developing a low cost RTU? Let me take you through the circuit. The first part here is potential transformers. These are responsible for fetching current voltage signal, and this is a current transformer. Now current transformer and potential transformer are together called transducers. Potential transformer is required to fetch the voltage signal, whereas current transformer is required to fetch the current signal. Now the current transformer, now we are basically constructing an overcurrent relay that will be able to communicate to the central station, which is the server. Now the current transformer will fetch the current signal. Suppose there is a fault. In case of a fault, there are always higher harmonics and a DC offset. So these need to be removed before the current is given to the numerical relay. So what we are using here is a UAF042 IC. Now I can show you. The UAF042 IC will be placed here and it will act like a bandpass filter. By the output that what this UAF042 IC will do is, it will give a bandpass of 45 to 55 Hz, and the output of UAF042 will go to the TMS320 F283790. Now TMS320 F27390, what is this? This is a Texas microcontroller capable of doing DSP and also capable of running the algorithm that we need for a numerical relay. Why have we selected DSP TMS320? The answer for that is, it is a DSP. DSP means digital signal processing. Now once fault occurs, we must know that by Parseval's relation, only the fundamental component will have the capacity to generate power. So only that component will have the power to cause any destruction if possible. So what we are interested in is fundamental frequency of current. To extract that fundamental frequency of current, we have to apply DFT or FFT, which is Fourier transform. Therefore we are using this microcontroller. Now we will tell you how we have constructed this circuit. From here we are getting a 220 volt supply, which is the main supply, right? We are right now not working under load. We are giving a very simple, we are just checking a numerical relay whether it's operational or not. We have already coded the relay, done the coding for relay in Code Composer. You can have a look on it. This is a platform provided by Texas Instrument only, and is capable of doing coding in Texas microcontrollers. Now this is what I was calling UF042. This is universal active filter. We can use it as a band pass filter. Now we can place this like this in the circuit. So the potential will come, the potential transformer will reduce the voltage, then the current transformer, we will pass a wire through this like in this manner when we will connect the load. Right now no load is connected, so I am just showing you how we can connect it, and it will sense the current and step it down and give it to the band pass filter. The band pass filter will filter out the harmonics and DC offset and will give it to the microcontroller. Now we have already programmed the microcontroller, and what I am doing is I am testing my microcontroller and just giving the a voltage signal of 5 volts, which is above the rated value, and see whether it will operate or not. Now what we have done is we have used pin number 34 as the output if there is a fault, pin number 31 as the output if there is no fault, and pin number 14 would be the input. We are giving an input of 5 volt signal from the transformer. Now what we will get is now Herman, if you can help me, a voltage signal is coming on 34 number pin. If there is a high voltage, I hope you have seen it, it is not stable. As you can see, the voltage is around 178 milliampere. This could be sensed by IoT. Now if I see at pin number 31, that is for no fault, which is pin 31, is this is pin number 31. This is pin number 31, and I will just need to have a jumper for it. Okay, now I can put it like this. Okay, thank you. Now just put it. Now you can see now have a look at the multimeter. Now you can see the voltage is very less, it is not stable. Just wait, it is not stable. The ground. Now you can see the voltage is very less, it is 0.1, it's fluctuating 0.4, 0.9. So this means that the voltage signal is not there on the 31 pin. Now basically what this microcontroller is doing is it is getting an input on 14th pin and is performing the sampling. That is, it is converting the analog signal to the digital signal. This is pin number 14, which is ADC pin. From pin number 31 and 34, which are our output pins, these are pin number 31 and 34, you can see, we are getting the output. If the current is above a particular value, that is after sampling, if it is greater than 2000, then the microcontroller will set 31 pin high, which means the fault has occurred. Sorry, 34 pin high, which means fault has occurred. But if it is less than 2000, it will set 31 pin high, which means fault has not occurred. So in this manner we can see whether a fault has occurred or not. Also we can connect this to an RTU and to an IoT and see on a server our results. Now finally what must be shown to you is how we have used this UF042 band pass filter. This is an active UF042 is a Texas active filter. We have used it as a band pass filter. For this we had to calculate certain values of resistances, and we have already simulated it on multisim. As you can see, this is our circuit on multisim. This has given us that how it has attenuated on different voltages and on different frequencies. So for this we have used a 6250 ohm resistor, 333 mega ohms resistor. So this is according to the data sheet that we had. Now at last, what are the benefits of a low cost RTU? The first benefit of a low cost RTU is, in India most of the distribution systems don't have any protection, right? So what we need to have is we can have a protection of distribution system, and RTU can be more beneficial in distribution system because along with preventing faults, what it can do is it can take necessary actions in case of overload. Therefore, it has great novelties and is applicable in many fields. Thank you. I hope you like the video.